So today we are going to start section 2.4, which is related to the binary arithmetic, and in this section we are going to discuss the addition, subtraction, multiplication and division, which is usually carried out with the readily available decimal numbers. Okay, so we are going to see that how these operations are carried out in the binary number. So before doing the addition in our today's lecture, we are here to see some basic operations or fundamental additions which will be useful throughout in this lecture. So here we have to see that in order to adding any bits here, so first of all we have to see that 0 plus 1 is always equal to 1 plus 0, and that is equal to 1. Okay, similarly 1 plus 1 is always equal to what? That is in decimal 1 plus 1 is 2. So in binary this will be equal to what? 1 0, because 1 0 in decimal is equivalent to the 2. Okay, because now you will, when you will convert it, if this is in binary, and when you will convert it, it will be 2 in the decimal number system. Okay, so I think it is clear. Similarly 1 plus 1 plus 1, this is in decimal is 3. So therefore in binary the binary equivalent of the 3 is what? That is 1 1. Okay, so these operations or these additions should be clear in your mind before diving into the details of our questions. So after doing all this, what we have to do, let us start our part A, and here we have to add 1 0 with 1 0. Okay, so let me add them. So 1 0 1 0, these two are the binary numbers, so I have to add them. Okay, so adding them, what I will get, this is 0 0, here it will be 0, and 1 1. I have previously told you that 1 plus 1 is always equal to what? That is 1 0. Okay, so that would be 1 0. So that is the binary number. Okay, and the addition of 1 0 and 1 0 gave me 1 0 0. Okay, so this is 2, this is 2 in decimal, this is 2. If you convert it, 1 0 is 2. Similarly this one is also 2. So when you will add them, you will get 4. Why? Because now you can see that this 1 0 0 is the binary equivalent of this 4, which is in the decimal number. Okay, so I think it is clear now. Similarly, in order to solve part B of my question, this is 1 0 with 1 1. So let me add them. So 1 0 with 1 1, adding them, what I will get? 0 plus 1 is here. I have done it already. So this is 1 plus 0 is 1, and 1 1 is also equal to what? That is what? That is 1 0. So 1 0 1 1 is what? That is the binary equivalent or the summation of 1 0 and 1 1. Okay, now similarly, so adding 1 0 0 with 1 1, so where should I have to write them? Because now here I have 3 bits, here I have 2 bits. So you have to keep in your mind that whenever you are given the number of bits which are lower than the other quantity here, so what you have to do, you have to start writing them from the LSB. Okay, so that is basically the lower significant bit, so you have to start writing it from, so that is here 1 and here 1 as well. Okay, so now let me add them, and when I will add them, this will be 0 plus 1 is 1, because here as well this 0 plus 1 is 1, and what is here is, as there is nothing here, so I have to write 0 here by myself, and 1 plus 0 is 1. Okay, so 1 1 1 is basically the output of my addition here. Okay, I have added them. Similarly, in part D of my question, what is part D? This is 1 1 1 and 1 0 1. So 1 1 1 and 1 0 1. Okay, adding them, what I will get? 1 plus 1 is how much? I have done it here. That is what? 1 0. So I have to write 0 here, and 1 will be carried here as the carry bit. Okay, so that is the carry bit. So now I have to add 3 of them. So 1 plus 1 plus 0, this is how much? Again this is 1 0, because this is now 2. So now writing 0 here, and again 1 will be the carry bit here. Now you can see that there are three ones, 1, 1, 1, and I have earlier told you that the summation of the three bits will be equivalent to 3 in decimal, which is equal to 1, 1. So now writing 1, 1 here, that is basically the summation of 1, 1, 1 and 1, 0, 1. Okay, so that is for my part D. So part E is, let me write it here. So here it will be 1, 1, 1, 1, 4 bits here, while this one here I have 3 bits. So following the same procedure which I have followed in our part C. Okay, so writing them from the LSB, okay, and the last bit here, making it 0 by myself. So now here 1, 1 is how much? That is 0, and here it is 1. Okay, now again 1 plus 1, 1 is 1, 1. Okay, so there it will be 1 will be carried here. So 1 plus 1 plus 1 is again 1 here, and 1 is also the carry bit here, and 1 plus 1 plus 0 is how much? That is 1, 0. So that would be 0, 1. Okay, so that is the summation of these two bits. Okay, the last one here is for your own practice. Add it and you will see that addition is not that much difficult as you were thinking about it. So that's it for today, in which we have seen that how to add two or more binary numbers by using the binary arithmetic procedure for the binary numbers. So that's it for today, and I will see you with some more interesting questions in our coming videos. Thank you so much. See you soon. So question 16 of the section 2.4, in which I have to perform the binary number subtraction. Okay, so what is the procedure here? So the part first of my question is here 1, 0, and from it I have to subtract 1. Okay, so in binary this one is basically 0, 1. So that is basically the 1, but how to subtract them? Here you have to keep in mind some very important stuff, and that is once you will have to subtract this from here. So you can see that here the higher number is 0. So 0 from 0 I cannot subtract 1. So therefore I have to take carry from the number which is at the left hand side. Okay, so what will happen if I will get carry from it? This 1, 0 will become how much? This will be now 2. Okay, so from 2 and 1 will be subtracted. What will I get? I will get here 1. Okay, so that is basically the essence of overall procedure here. Similarly, if I will have this number here and I have to subtract something from it, what will happen? Here I can see that I cannot subtract 1 from the 0. So I have to take carry from the next item on my left side. But here this one is also 0. So therefore it will also look at its own left side. So therefore it will get what? It will get 1 carry from it. So I can see here that it will be 0, 0. When it will get this carry from here, what will it become? It will become 1, 0. Okay, so this is now 1, 0 is how much? This is 2. Similarly, when it will give it to the right, what will happen? So this 1, 0 when give carry to the right hand side bit, what will happen? It will not be like 0 will remain here and 1 will be shifted there. No, it cannot be like this, because now this number here is 2. So when it will give 1 to it, okay, what will remain here? It will become 1. Okay, because from 2 it will get 1 here, so 1 is left here. So that is the concept which you will be using here. Okay, so let me start solving these questions, and with the passage of time you will get to know that how did I solve this question. So this part A of my question, here I have 0 again, and at the lower side here I have 1. So I cannot subtract 1 from the 0. So it has to take this carry here. Okay, so when this will take carry here, it will become 1, 0. So 1, 0 is basically 2. Okay, so from 2 I have to subtract 1, and therefore here I will get 1. Okay, so when it has taken this 1 carry from the left hand side, what did I left here? So it was basically 0 here. 0 minus 0 is how much? This is now 0 as well. Okay, so that is basically the subtraction here, in which I have subtracted 0, 1 from this 1, 0, and here I have got this 0, 1. Okay, that is the binary subtraction. Similarly, when I have to subtract 1 1 from this 100, what would happen here? The second scenario which I have covered here, you can see that here I have covered the scenario which is here. So how did I do it? So you can see that this is 0 and from it 1 cannot be subtracted. So therefore it will look into the left hand side bit. So it has to get carry from it. It cannot get carry from it because this is now again 0. So therefore it will ask the left hand side of its own. So therefore this is 1. When it will give it a carry, what will happen? This will become 1 0. 1 0 is 2, which is already mentioned here. So when this 1 0 will give 1 carry to 8, okay, because this is the required weight here. So this will become 2 now, while 1 will remain here because this was 2, and when this 2 will give 1 here, 1 will remain here as we have discussed here in this question. Okay, so therefore this is 1 1. So this is basically how much? This is when 1 will be given to 8, this will become 2. So 1 0 is 2, 2 minus 1 is this 1. Okay, similarly, how much is left here? This is 1. So 1 minus 1 is 0, while this is also 0 because this bit was carried from the right hand side bit. So this is now 0 0 1. So this is the result of the subtraction from these two numbers. Similarly, when I have to subtract this 100 from 110, what would happen? So let me write this 110 here and 100 here, and I have to subtract them. This 0 minus 0 is 0. This 100 is 1 0 subtracted from 1 is 1, and 1 and 1 subtracted from 1 is 0. Okay, so that is the binary equivalent of this number. Okay, so that is for this number. Similarly, part D of my question, this is basically a 4-bit number, and similarly here I have this 2-bit number, and I have previously told you that whenever I have the lower number of bits here, so what you have to do in the MSB, you have to write these zeros. Okay, so now in order to subtract them, 1 will be subtracted from 1, this will give me 0, this will also give me 0. Okay, this will be 1 and this will be 1 as well. Okay, similarly, part E of my question, 1 1 0 1, okay, and 1 0 1. Again subtracting them, 1 minus 1 is 0 0, 1 minus 1 is 0, and here this one as well. Okay, so that is the last question, and I have left it for your own practice. So in this question, what I have done, I have basically carried out the binary number subtraction, and you can see that it is now very easy to subtract one binary number from the other one if you have these two confusions which I have mentioned here clear in your mind. Okay, so that's it for today, and I will see you with some more interesting questions in our upcoming videos. Thank you so much and see you soon. So question 17 of our book, in which we are asked to perform the binary multiplication over the numbers which are given here in different parts. Okay, so let us start part A. Okay, and here we have to multiply 1 1 with 1 0. So what we have to do, first of all, you have to write one number here while the other number beneath it. Okay, and you have to multiply them. What are the steps of multiplying them? Okay, what you have to do now, you have to take this first number and multiply it with first with this one, then with this one. Okay, similarly, after it, what you have to do, you have to take this number, okay, and you have to multiply it with this one and then with this one as well. Okay, so in this way you will get some numbers which you have to add together, just like we used to do with the decimal numbers. Okay, so let me start it here. So in multiplying it, first multiplying the 0 with 1 here, so 0 multiplied by 1 is 0. Let me denote it with the red color. Similarly, 0 multiplied by 1 is again 0. Okay, now this 1, and let me denote it with this green color. So multiplying this 1 with this one first. So first of all, making here this one, and what does it mean? It means to make this space blank. Okay, so this space is blank and I am representing that blank space with the help of this cross. So now 1 multiplied by 1 is 1. Similarly, 1 multiplied by this one is also 1. Okay, so this one is here. What we have to do, we will add them together. So as this cross is basically the blank space, so 0 will remain here. Okay, similarly here 0 plus 1 is 1, and similarly this space is again blank, and blank space is considered at 0. So 1 plus 0 is 1 here again. Okay, so the product of these two numbers is 110. If you see that this 1 is basically 3, this 10 is what, this is 2, so their product is basically 6. So let me see whether this is 6 or not. So this is what, this is 2 to the power 0, 2 to the power 1, 2 to the power 2. Okay, so when these will be multiplied and added together, you will see that at the end, by adding them, this will be multiplied by 0. Okay, so at the end what you will get, this 6 as well. So it means that our product is correct, and the answer of in decimal number is 6, while in binary multiplication the answer is also consistent. Okay, so that's for part A of my question. Let me start it for part B of my question, and I'm going to do it directly. So starting it for 101, okay, and multiplying it with 1 1, what you have to do, you have to multiply them. So 1 multiplied by 1 will be 1 1 0 0. Okay, 1 1 is 1. This one will be blank, so I have to start it from here. So this one will multiply, this one will be multiplied here. So 1 1 1 1 0 0. Okay, and 1 1 will be 1. Okay, so now this one will remain here because this space is blank. So therefore it will be here. So 0 plus 1 is 1, this will be 1, and this one will also be 1. So that is the answer of these two. So what is it basically? So let me again check it. So 101 is how much? That is 210. So this these two terms will remain same. So this will be 4 plus 1 is 5. Okay, 5 multiplied by this one is 3. So it should be 15, and we will see that by converting this one into the decimal number, we will see that this is also 15. Okay, so it shows us that our multiplication is correct. Okay, so that is the product of these two numbers. Similarly, now let me start it for part C. Okay, so for part C, I can see that this is 111 and 110. So now I have three numbers, I have to multiply them by using the same procedure. So this 0 will be multiplied with these three, and I will get 0 0 0. The procedure will remain same. This will be the blank one, while this one, when multiplied with 1, all the threes, I will get here 1 1 1. Okay, so whenever you will have a third bit here which you have to multiply with all the numbers, so here I have given it one space. So now in order to write the third product here, what I have to do, I have to give it the two spaces, okay, from the right side. So 1 multiplied by 1 will be 1. Okay, so I have to start it from here. Similarly here and here as well. Okay, so here I will get this one. So this one will be 0 now. Now 0 plus 1 0, as this is blank, so here again this is 0. Okay, so 0 1 1 is how much? This is 2. So 0 and 1 will be carry here. Okay, so 1 1 1 is 1 1. Okay, and here this 1 1 is how much? This is 1 0. So that is basically the product of my two numbers which are given here. Okay, so that is for this number. Similarly, for part D of my question, what I have to do, again I have 1 1 0 0. Okay, and similarly 1 0 1. So multiplying it by using the same procedure, first of all this will be multiplied with the upper 4 bits. So what will happen, I will get 0 0 1 1. Okay, then this blank space, and the 0 will be multiplied with all the numbers, and I will get here zeros. Okay, 4 zeros because the numbers here are 4. Similarly, the third bit, when multiplied with them, I have to give it 3 spaces. So this will be 1 0 0 1 0 0 1 1 1 and 1 1 1. Okay, so this will be the number. So 0 will be here. This 0 plus 0 is 0. 1 0 0 is 1. 1 0 0 is 1. Okay, this 0 plus 1 is 1, and this one here as well. Okay, so that is basically the binary equivalent of the product of these two numbers. So, the overall procedure will remain same for all the number of bits, but just you have to do that if the number of the bits will increase for the multiplying term. What you have to do in writing the product of those numbers here before addition, you have to give them space away from the previous bit. Okay. So, the overall procedure will remain same for the part E and part F as well. So, it is for your concept that how the multiplication of the two or more than two binary numbers can be performed. So, that is it for today, and thank you so much for all your concentration, and I will see you with some more questions with some more interesting stuff in our upcoming videos.